6.2 Inverse Functions and Relations. So this should be a pretty easy section. We're going to go through this pretty quickly, but the inverse relation is the set of ordered pair. I'm reading right above here. The set of ordered pairs obtains by exchanging the coordinates of each pair. Okay, that means switching. So that means the domain, the x's of the relations, become the range of its inverse, and the range of the relation becomes its domain. Okay, so look how easy this is. The inverse relation. Two relations are inverses relations if and only if whenever one relation contains the elements of AB, the other contains the elements of BA. Therefore, the inverse of A, 1, 5, 2, 6, 3, 7. The inverse of that is 5, 1. I change the x and the y. 6, 2. I change the x and the y. 7, 3. I change the x and the y. Easy as that. I'm not trying to trick you guys. So the inverse says find the inverse. Well, here we go. That's a set. We want to do that set. The inverse, we switch the x and y's. 10, negative 9. Notice I'm not switching any signs. I'm just switching the positions. Negative 3, 1, and negative 5, 8. And you're done. Let's look at number 2. The inverse. 9, negative 2, negative 1, 4, 9, negative 7, and 0, 7. Those are the inverses. All right, let's look at the graph. This is really cool. So beforehand, we used to do the vertical line test. If you remember that from last semester, it's awesome. The vertical line test. The vertical line test, remember, is I told you guys, let's see, if we had a graph, let's say our graph looked like that, and we took a pencil, right? And this is going to be my pencil. And we moved it through this graph, okay? We moved it this way. If it ever hit my graph more than once at the same time, it was not a function, right? This is my graph right here. So this would be a function. Yes, this is a function because it never, my purple pencil, would never hit any of these lines at the same time, vertical line test. Now, if I were to take the inverse of a graph, what you would do is you wouldn't do the vertical line test anymore, you would do a horizontal line test. So this says, when the inverse of a function is a function, the original graph is 1 to 1. We learned that all the way back in chapter 1, I believe. Recall that a vertical line test can be used to determine whether the relation is a function. Similarly, the horizontal line test can be used to determine whether the inverse is also a function. So let's look at here. Right here, this is f of x. This is a function because it meets my vertical line test. Okay? It's a function. F of x is a function, yes, because it meets the vertical line test. Now, our question is f of negative 1? That means inverse. That negative 1 means inverse. That should be a review. Is that a vertical line test? Well, then you would do the horizontal line test, right? So if I make my horizontal line, start at the bottom and go all the way through, would it ever hit twice at the same time? Nope. So yes, this is also a function. The inverse is a function. Let's look at g of x. Okay, is g of x what we're looking currently at right now? That looks like a kind of a funny W. Is g of x a function? Yes. Is the inverse of g of x a function? The answer is no, because this red line is my horizontal line test, and it hits more than once at the same time. Okay, even if I ran it up here, it would hit here and here. So no, the inverse is not a function. All right, so now that says, oh, I kind of went over this one where it's highlighted. How do you write the inverse? F of negative 1 times x. Now, here's the thing. We're not going to say f of negative 1. Okay, the mathematical language of that, you would say the inverse of x. So whenever you see a negative 1 up there, we don't say f of negative 1, say that's the inverse of x. So here it goes. It says find the inverse of the function, then graph the function and its inverse. We're going to have two functions on one graph. And I'll tell you guys what I want you to do for that. So first, let's find its inverse. Here's how you find the inverse. Step 1, you're going to change, or let's not use change. Let's use the word switch. You're going to switch x and y. Step 2, you're going to solve for y. So let's look at this first example. This is y equals negative 3x. So step 1, I'm going to switch those positions. So now it's going to say x equals negative 3y. And step 2 says solve for y. I need to get y by itself because that's how I'm going to graph. Divide by negative 3. So y equals 1 or negative 1 over 3x. All right, let's graph. Okay, I will use this color. I'll stay consistent. Let's first graph this. My b is 0. My slope is negative 3 over 1. So here's 0. I'm going to go down 3 to the right 1. And up 3 to the right 1. Now you have two options. You are either going, well, no, we're going to label this. You have to label your graphs in order to get credit. So this graph is f of x. Okay. If you want to use different colors, that's great. But sometimes when you submit it, you don't submit the colored copy. So you have to label graphs. Let's do this one. I'm going to do this one in purple. So again, my b is 0. My slope is negative 1 over 3. So 0, down 1 to the right 3, down 1 to the right 3, up 1 to the left 3, up 1 to the left 3, and there's this function. And that's the inverse, right? So how do you write the inverse? F to the negative 1 of x. Okay, so there's your answers. The answer is the inverse, which is right here circled in purple, and those two graphs. Okay, let's look at 5. Okay, let's find the inverse. So this is y. So I'm going to switch. X equals y squared minus 3. I'm going to solve. I'm going to get y by itself. So I have y squared equals x plus 3. Now how do I get the square out of there? I square root both sides, and I put a plus or minus there. So I have y equals plus or minus radical x plus 3. Okay, so I have an interesting graph here. Let's graph this. I'm going to go out to 6. Okay, now if you remember so h of x is equal to x squared minus 3. If you remember, this is going to be a u, right? And we had x minus h squared plus k, with our vertex being hk. So you can do that. If you can do that, that's great, because my vertex here is 0, negative 3. Okay. And there's h of x. Okay. And then this one here, you may not remember how to do this. So what I would recommend for the square root is let's plug this into our calculator. So let's go to y equals. y1, we're going to make the square root of x plus 3. And y2, we're going to make the negative square root of x plus 3. That's what's going to get our u to go down. So square root, so you would hit second and then x squared. And then you're going to plug in x plus 3. Okay, and then you're going to do the y2. So that gets us right here. And there's one goes this way and one goes this way. Now this is the inverse of it. Okay, that's our answer. Now for extra credit, I could say, are these functions? Okay, and for the green one, you would say, no, this is not a function. Again, this is extra credit. Are these functions? For the green one, you would say, no, it's not a function because it doesn't pass the... Oh, I'm sorry. Let me rewind. The green one is yes, it's a function, right? Yes, it's a function because it passes the vertical line test. Okay? Then you would do the horizontal line test and you would ask if it's a function. Now you're doing the horizontal line test on the green graph. Okay? You're doing the horizontal line test on the green graph. So is that a function? And your answer would be no. So h, the inverse of h, is not a function because it does not pass the horizontal line test. Okay? Again, I don't have to look at the pink one. I have to look at the green one. But there's that one. Okay, this one here we'll go over more. These are just some word problems that I want to do with you guys in class. So last but not least, let's look at this one. Determine whether each pair of the functions are inverses. Right, yes or no. Okay, there's a number of different ways to do this. I think the best way to do it is you want to find the inverse of each of them and make sure they match the other one. Okay, so again, first I'm going to take f of x. I'm going to find the inverse of f of x and see if it matches g of x. And then I'm going to take the inverse of g of x and see if it matches f of x. Okay? So let's take the inverse. Let's start here. This would be x equals y minus 7. Add 7 to both sides. Y is equal to x plus 7. Yes, it matches. Check. Okay, let's figure out the last one. This would be x equals y minus 7. And, oops, I'm sorry. Okay, this is it. Plus 7. Subtract 7 to both sides. So y equals x minus 7. This matches the other one. So check. Okay. And then these ones get a little bit more complicated, which I want to do with you guys in class. This is the notes for 6.2.